Again, Markus Nispel, VP Solutions Architecture and Innovation. As part of the Network Field Day 7, a quick live demonstration of our Purview solution, starting with different workflows that you can typically go through and get a better understanding of our capabilities here. So, can you see that? Probably the video is challenging to read, but let's start with the initial dashboard. Gives you an at-a-glance overview of what happened in the last hour. Total unique applications that we've seen in that network: 3,060 gigabyte of bandwidth, 1,100 clients, 2.5 million flows, 779 servers, and an average network response time of 28 milliseconds, which is good. As a network vendor, we should have a decent network. Makes sense. And also, average application response time isn't that bad, 65 milliseconds. What you see down below, and you can obviously change for your, it's always the last full hour, but you can roll back and forth between dates and times as you want to. What we show here is the split in terms of data volume per application group. We detect today more than 7,000 applications, and we group them in 30-ish application groups. All of that can be modified, but that's what we do by default. Down here you see again these application groups like business applications, cloud computing, cloud storage, etc. Over time, in terms of bandwidth by packets and bytes, flows, number of clients, etc. And then you can start to drill down from that. Different dashboard types to start from. Interesting here, we already have a breakdown of applications, Ixia and terraces, still here somehow, which is interesting. It's basically the worst application response time, because that's the old web page that we deprecated, so the new one should be really fast. So that is good. And going down from here, weather channel seems to be interesting.
What's cool about that is actually that you're classifying websites by as applications and what they are, rather than having a block that's 80% of the traffic that says HTTP.
Yeah,
right, because that's what most tools do, right? It says HTTP, here it is.
Yeah, that
and then you need to go to your web content filter, web logs. That's
but that's pretty uninteresting not to split it out. So as what I said before, that auto split out web app rule, we call it, we just extract automatically host and common names and URLs and create dynamically applications based on that. For weather channel, I need to see whether it's that automated rule or whether it was a different one, which we can dig into in a second. Yeah?
Well, it's even more than interesting. I mean, websites are applications now. I mean,
that's what I'm saying. They're applications, right?
Yeah, that's our definition.
It's useful. It's useful.
Yeah,
it's actionable.
Yeah.
I mean, that's one of the big. When you talk to the NFL and you talk about what they want to see what sites are their users going to. They want to see, is there a lot of traffic? Are their own properties, NFL.com and otherwise, actually being used, or is everyone going elsewhere? And how can they then change behavior, make it more valuable? Is it a response time issue? Is it an issue with the applications themselves? And they can start to then tune their marketing as well. And as Markus said, within the stadiums, not the NFL per se, but say the Patriots, for example, who are also a customer, both from an analytics standpoint and from a Wi-Fi standpoint, they can use location-based services to see who's doing what on the different levels. So the 100 level might have some behaviors. The 200 level is the club level. You'd imagine those folks have a different set of behaviors and interests. And they can start to tailor, their beer offerings on the 200 level is going to be different than their beer offerings on the 100 level. And do they want to vary it in by end? Do they want to change things so they can enhance the overall customer experience in ways that are much better than they could before?
And I'm not saying this jokingly. It actually leads to businesses like that to software-defined marketing. When you guys have API hooks to this, I'm not trying to
You should coin that term now.
That's stupid about it. SDM. But there's a wireless provider who's actually now collecting, not connects to the network, but just people polling as they walk by to show the number of people who walk by that building. And this is similar, and if you can extract that data in an API, then you can work with Google or whoever else from an AdWords perspective. You can dynamically on the fly change your ad structures on the go.
Yeah, actually we are doing that already. So there are conversations going on. Yeah, a lot of not only in the context of NFL, but that triggered a lot of interest of companies doing those kind of things. Yeah. And whether it's ad placement or you have a Facebook channel back into that user or whatever. So there are multiple interesting new use cases, and for us it's basically a whole new market. Yeah. That's why, getting back to your initial question, will it be a standalone business? It needs to be viable in those markets as well. Yeah. Okay, so
is this HTML5?
Yes, partially it's HTML5. It's not full.
It's not Java. Is it Flash?
Is it? No. It's more HTML5 than it is Flash. So what we use, our server component is a Java JBoss infrastructure, and there are some graphic elements that are delivered with that. I forgot the name of the package that we are using for that, but it's mainly HTML5 based. Yeah. Okay. So the fingerprint, so as I said, you can do drill downs from here, look at top clients for the weather channel, slowest clients for weather channel, all application flows for weather channel, application usage, as well as the fingerprints. And I just looked it up. We had 3 fingerprints for the weather channel already in place, which just you can see here. So from so there are multiple dashboards to look at. One dashboard that reflects the best the notion of the analytics component to it is the application browser. The application browser can be used to slice data from different perspectives and look at data differently. Yeah? So let's take applications, and we can do applications, clients, profiles, locations, etc. by bytes. In the last 24 hours, for all locations, you will see that storage CIFS is the #1. Interestingly enough, NBC Sports is pretty close, so Olympic Games are of interest, yeah, which is good to know. Yeah.
Is that watching this network too, that we're on?
No.
No Twitter?
No. But what is interesting to see, as you're changing that perspective from bytes to flows, as I said before, you see that it's mainly DNS, zip, and a lot of Outlook Office, which is interesting. It's probably some hello stuff from Lync going on that we need to dig into. Yeah? But then you can start to slice data differently and say, okay, I want to see that for all of my sales teams and how the application usage profile looks like here. And you see our sales team is doing a lot of Salesforce, which makes sense, which is our CRM tool that we are using. On the other hand, our marketing teams using a lot of Twitter. Yeah? Here we go. Yeah. Yeah.
They might be out tweeting you guys. I've seen a lot of tweets from the Extreme account.
And then you can also start to dig into that, split it by location, Salem versus Raleigh versus whatever. And you can also then go deeper into that kind of data and look at the users, for example, the slowest clients, if you have a bad application response time, who is affected with that, and things like that. Yeah. And as you connect that data also from a troubleshooting perspective to device data, you are able to, something shows up here. Should be able to tell which access point a user is connected to, whether that access point has certain problems and things like that. So we are really also bridging the gap between those different management disciplines. Traditional network management, access control, application management, it's all tied together in one database, so to speak.
Are you able to look in any QoS parameters?
Not today. That is something that is on the roadmap for sure, yeah. Needs to be. I mean, that's the next logical
Well, you're
step,
gathering all the
so
data, right?
Visibility first, policy enforcement afterwards. So the policy enforcement framework is still a traditional framework up to layer 4, but we obviously want to enhance that to applications, so there's no doubt about it. Yeah. So just mapping that back, you should be able to the security feature.
Yeah, so the way we have this implemented, there's actually 2 separate servers, because one was an engineering server, the other one was our corporate server, so that's why it's jumping between servers.
So for something like this where you're able to hammer down and you see Twitter in there. Twitter, you can use a client that accesses the Twitter API,
yep.
and you can use a web browser
Yep.
on Twitter. Is it fingerprinting those 2 and grouping them under the same thing?
That is a good question, and we will find out by looking at our Twitter fingerprints.
You know, probably, because my thought is it'll show up as application JSON or application XML, and if you're browsing the web, then no.
Yeah,
and that's in the HTTP header,
yeah.
So that can be fingerprinted.
Actually, we have a lot of Twitter fingerprints, so we use a mixture. So it's, I think it's, to a degree, it's the app itself. Twitter user agent string is looked at, HTTP host names that involve Twitter, so different mechanisms.
Oh, so you can break it down from images because of that.
Yeah.
Yeah.
It uses.
Yeah.
That's awesome.
Yeah.
Yeah. Cool.
So that's something you can do as well, and cloud storage. So that is basically the application fingerprint configuration as well. So you can also start to look at all of the fingerprints here, modify them, find out how many matches you had, etc. But we really started from a troubleshooting perspective, going really down to the user and all of the user-related data around where is he connected, which network component, how is the performance of that network component, were there outages and things like that. Yeah. Another option, so actually what you've seen before on PowerPoint, that's really part of a product. That's also pretty cool. So, and actually it was vice versa. One of our SE managers came up with a mock-up where he wanted to present the kind of data that we show in our product, and from a product development, we liked it so much that we said, okay, we take that and make it part of our presentation layer. So you end up with that fingerprint, if that user here would be wireless connected, then we can also provide wireless location services as said before, and then start troubleshooting from here, seeing the AP, all connected clients to that AP and things like that. Did I say before the network was fast?
Well, we are VPN back to New Hampshire.
It's all of the delegates eating the bandwidth.
Well, you threw down the gauntlet and said somebody was out tweeting us. So.
There you go.
Wanted to load test those flows. There we go.
Okay, so while this is loading, one other way on how to look at data is the response time. That's always very interesting to look at. There's a different way on how that can be presented. Might have seen that before as well. So you see the applications with the best or worst response time, and then you can see who is experiencing Huffington Post as a bad performance application. That should be our CMO, because he's always contributing blogs to Huffington Post. So let's see whether that's true. So the slowest clients listed here, so you can see again who's being impacted by a bad application response time from our application Huffington Post. Yeah. Loading takes a while. So in between, while this is loading, you can already see that we were able to locate that particular user from before, and then you see he's close to that access point, and then you can start even looking at access point data, access point performance, and things like that. So it's pretty nicely integrated from a database perspective, which we consider one of our biggest strengths, being able to bridge the gap here. Yeah. Okay. Last but not least, application flows, something to look at as well. We can always look at the raw data in the appliance cache that includes all of the flow specific information. That includes all of the metadata. It's hard to see, huh? But yeah, boy. All of the metadata of a specific flow. Yeah. User agent string, language, operating system, cookie information, and so on and so on. And again, response times are measured here as well. And from here you can also create or modify your existing fingerprints if you want to as well. So that's possible.
So with all this flow data, and I've asked this at other field days of other people who are in network management spaces, and you guys even more so than a lot of them because it's all flow data, you're half a second away from being able to take action on that data at a controller level. Is that something you're doing, or again, is that going to be something that you rely on the market to give you the tools to use that flow data?
No, that's on, how do we say that's on the roadmap?
On the roadmap.
Yeah.
Okay, so you see the value in it, you see what you have.
Oh yeah, no doubt about it.
One of the things that we've done well with respect to policy implementation is being able to do one-click policies across the network very seamlessly through NetSite. And with this, we'll in the not too distant future, be able to do the same from an application standpoint. So if you want to say, okay, well, I'm not going to let Fred look at, Twitter when he's on his corporate account, I can set that policy.
Well, I'm not even saying that. That's more knack stuff. I'm talking about being able to say, I'm going to steer this class of traffic this way.
So I envision
a good example
are more QoS policies, bandwidth policies.
Yeah. So a good example is we have one of the large universities down in Southern California. They've been approached by the studios, say, hey, we want to fund you for this, but we want to make sure your students aren't pirating our IP, aka stealing movies via BitTorrent and other mechanisms, right? So with this, they can actually rate limit these certain applications down to next to nothing. They can say, hey, we still have an open network, you're able to do stuff, but it forces the student to go across to Starbucks to do that BitTorrent type activity. Yeah. That's of a huge value to them to be able to say, hey, Mr. Spielberg, we'd love to take your money and we want to set up this, great foundation. And by the way, we can be sure that none of our students are pirating your intellectual property. And we can do it in a way that still allows the school to say, we let the kids do what they want with the network, quote unquote. Right?
You would be surprised also how many automated uploads take place in a stadium that don't really contribute to a good user experience. That all of the background tasks, iCloud, whatever, they all kick in, and that's obviously very beneficial to have.
Yeah, so you could set policies in that's just going to rate limit that sort of activity to a certain amount of bandwidth, certain amount of or shut them down completely if that's what you want to do. And that's a relatively new phenomenon. The automated updates we saw just within the last 6 to 12 months or so, where all these devices now, instead of asking for permission to update, they're doing it on their own.
And funny enough, they don't do it on LTE because they think it's too slow. So the client itself doesn't do it, but as the client gets Wi-Fi connected, suddenly all of those things kick in. So the Wi-Fi networks get all of that load. Yeah. So in terms of policies, for sure, the framework, our policy framework that exists for a long time, will be augmented to include that. It will also streamline the policy definition. I mean, right now, policy means IP address, subnet A, port 80, allow, deny, VLAN, whatever. Tomorrow you say weather channel 2 megabit and you're done. So the policy definition itself is much easier and streamlined. Yeah.
Could we
Yeah.
So,
and you can also do application traffic engineering based on that, which is another interesting component to it if you want to start to steer traffic.
Could we flip a DSCP bit to say CS1, put it in a scavenger class, so other parts of the network could react accordingly?
Yeah. Or the switch itself also starts to do rate shaping and rate limiting as well. Or if you mark it with a different diff of control point, you can map it into a different.
Because I'm thinking I may not
label, whatever.
I may have other bottlenecks in my network that aren't extreme switches, and if I could put that into the scavenger class, then I can take advantage as needed there.
Yeah, so policy itself for us can include marking, QoS, rate limiting, rate shaping, access lists, VLAN assignment, mirroring, redirection, and other things. So it's a pretty flexible framework. It's not only access control, yes, no, it's much more than that. Okay. What else? Specific use cases you want to cover? Oh, one thing I forgot. I know why I forgot that, because you're logged in as
read-only.
Read-only, yeah. How do I most effectively re-log in? Can I log out? Just close it, it's probably best. So just one last thing I want to show.
Broke it.
Wait and see. Yeah. So we always like to take the risk of a true live demonstration. So sometimes it ends up in at least a few seconds of waiting. Yeah, no, it's still cached. Okay. I just wanted to
log out.
All right, there we go. Oh. Now we get to configuration, which then gives a very good idea of the data rates coming in. So as we said before, one flow per second per client is typical. What is really interesting to see, the default mirroring is configured on those switches in that setup to 15 packets. But if you look at the flow rates here, which is 600 per second, we see 2,500, 2,600 packets per second typically. So the average mirror number per flow is just 5 packets and not more. And that is really attributed to all of those super short DNS, SNMP flows that are basically not real flows. It's just single packet exchange going back and forth. Yeah? And for those, policies are much harder, obviously, or let's say impossible, as by the time you detect those, they are gone. So you need to detect those much closer to the real source. But for all other data transmission taking place that goes beyond that, it's pretty easy to enforce policies.